let's do some math, guys. All right, I already told you in the previous video that if you have the hydronium ion concentration and you multiply it by the hydroxide ion concentration, you will always get 1 times 10 to the minus 14. Okay, so since we know that, if I give you the hydronium ion concentration, you should be able to find the hydroxide. All you have to do is plug this number in here and solve for this unknown here. So you would go you would go, let's put it up here, 1.00 times 10 to the minus 2 times x is equal to 1.00 times 10 to the minus 14. So you have to divide this side by 1.00 times 10 to the minus 2, divide this side by 1.00 times 10 to the minus 2. You do the math, and this one you could do in your head, or you can use a calculator if you want, and you get 1.00 times 10 to the minus 12 molar. Okay, so that one's pretty straightforward. Now this one you definitely need a calculator for. I gave you the hydroxide ion concentration, and I want the hydronium ion concentration. So what do? You go x times 2.60 times 10 to the minus 5 is equal to 1.00 times 10 to the minus 14. Divide this side by 2.60 times 10 to the minus 5. Divide this side by 2.60 times 10 to the minus 5. Okay, now you pick up your calculator, depending on which calculator you guys have. Remember, anytime you have exponents in the denominator, put parentheses around them, okay? So I'm going to use this handy dandy pink one. I'm going to go 1 times 10 caret minus 14 divided by, open parentheses, 2.60 times 10 caret minus 5, close parentheses, equals, I get 3.85, because it's 846, but I'm going to round it to 3 sig figs, 3.85 times 10 to the minus 10 molar. Okay, that's what I got here. Now, if you have a different type of calculator and you're using the EE button, you could do this. You could go 2.6 EE. Forget that. 1.0. 1.00 EE, if I can find it, EE negative 14. 1.00 EE, or E negative 14, divided by 2.60 EE negative 5. And you end up with the exact same number. You end up with 3.846, et cetera, times 10 E, 10 to the minus 10, which is 3.85 times 10 to the minus 10. When you use the EE button, remember what I told you guys in the beginning videos, don't do the times 10 to, okay? The EE represents times 10, okay? When you're using the caret button, though, on these types of calculators, you are going to have to go times 10 to the caret, and then always put parentheses if anything's in the denominator, or if any exponents are in the denominator. All right. So what does all this mean? What's the purpose of all of this? Okay, here's the deal. If the concentration of the hydronium ion is more than the hydroxide ion, the solution is acidic. If the concentration of the hydroxide ion is more than the hydronium ion, then the solution is basic. So let's take a look here. This is 1 times 10 to the minus 2. This is 1 times 10 to the minus 12. Which is a bigger number? 1 times 10 to the minus 2 is a much bigger number than this one, because minus 12 means you move the decimal 12 places to the left. Really tiny number. This one is only 2 places to the left. So this solution here is acidic. Why? Because the hydronium is more than the hydroxide. Okay, let's take a look at this one. We have the hydroxide is 2.60 times 10 to the minus 5. The hydronium is 3.85 times 10 to the minus 10. Which is a bigger number? This is bigger than this. Again, the 10 to the minus 5, move the decimal 5 places to the left. This one have to move the decimal 10 places to the left. So this is more than this. If the hydroxide is more than the hydronium, this solution is basic. Okay? So let me give you a little cool summary that will help you guys out. If the hydronium ion is equal to the hydroxide ion, that means they're both going to be 1.00 times 10 to the minus 7. If that's the case, the solution is neutral. It's not acidic, it's not basic, it's neutral. If the hydronium ion is more than, greater than the hydroxide ion, the solution is acidic. In that situation, usually the hydronium, not usually, always the hydronium ion is more than 1.00 times 10 to the minus 7 molar. So if you ever see a hydronium ion more than 1 times 10 to the minus 7 molar, bigger number, it's going to be acidic. You don't even have to do any math. You can just tell right away. Why is 1 times 10 to the minus 7 the neutral? Because it's the only time when they are exactly the same. 1 times 10 to the minus 7 times 1 times 10 to the minus 7, all you do is you add the exponents, and minus 7 and minus 7 is minus 14. Okay? The other scenario, if the hydroxide ion is greater than the hydronium ion, so if you have more concentration of hydroxide is more than hydronium, and if the hydroxide ion is greater than 1.00 times 10 to the minus 7 molar, what is the solution going to be? Basic. Okay? Good. So if I give you a list of hydronium and hydroxide solution concentrations here, and I tell you, is this solution acidic or basic? All you have to do is follow this summary that I just gave you, and you'll know. If they're both 1 times 10 to the minus 7, it's neutral. If the hydronium is more than the hydroxide, it's acidic. If the hydroxide is more than the hydronium, it's basic. If the hydronium is more than 1 times 10 to the minus 7, it's acidic. If the hydroxide is more than 1 times 10 to the minus 7, it's basic. End of discussion, okay? Now, most people don't like exponents. They have a really hard time with it, and that's why they really developed the pH scale. The pH scale gets rid of all the exponents, and we use logarithms. So let me write down what the definition of pH is. pH is minus the log of the hydronium ion concentration. Okay. pOH is equal to minus the log of the hydroxide ion concentration. We'll talk about pOH a little later on, but let's focus on pH. You've all heard of the pH scale. You've heard of the terminology pH balance. This shampoo is pH balanced, or this product, this soap is this and this. What is the pH scale? pH scale goes from 0 all the way to 14, with 7 being neutral. It's an exponential scale, which you're going to see that every 1 unit of pH means 10 times. So a pH of 1 is 10 times more acidic than a pH of 2. Anything below 7 is acidic. So as you go down, it becomes more and more and more and more and more acidic. So 7 is 10 times less acidic than 6. A pH of 6 is 10 times more acidic than 7. Now, as you go above 7 all the way to 14, it's basic. Which is the most basic? 14. So 14 is 10 times more basic than 13. All right, as you go this way. But this way, the lower the number, the more acidic it is. So if I have a pH of 1 and a pH of 3, 1 is 100 times more acidic than 3, okay? Because there's a pH of 2 here. 2 is 10 times more acidic than 3. 1 is 10 times more acidic than 2. So 10 times 10, 1 is 100 times more acidic than 3. So when we talk about a pH change, we're talking pretty dramatic changes if it's going a full unit. All right, we're going to learn how to use logarithms in the next video, and we'll learn how to calculate pH. Okay?